Okay, we are back from the break for Christmas. And we will be covering mass calculations. It's all going to be separated, but the problem with this type of area is it's all going to be numbers, and you do have to show all the work. So you may want to put this in a notebook, and I will be doing spot checks as far as the work. So if you are chosen as part of showing your work, if you don't show the work that I'm requesting, your grade will be entered as a 50% or lower. So you need to make sure to go through and do the work. Now, do you have to show every single one of them? No. If you have like 20 problems, again for an example, if you show me 10, I'm fine with that. But I just need to know whether you guys know how to do it or not. So first of all, we're going to do mass calculations. Again, I'm going to show you an acceptable way as far as showing the work. So basically what I have to do here is I have carbon and oxygen as my elements. Now I do have to count my number of atoms for each one. So this is going to be one carbon, and this is going to be 2 oxygens. Now, next thing you're going to need to do is go to your periodic table. You're going to use the mass, which is usually at the bottom part. Now, for purposes of going quickly, we are able to round them to the nearest whole number. There are only a couple of them that you need to use something else. So let's say we're going with carbon. You're going to see the mass is going to be 12.011, which rounds to 12. So what I would do is 1 times 12 is 12. Now the other one is oxygen. Mass is going to be 15.999. Thank you. So I'm going to have 15.999 as my mass. I'm going to round that to 16. And that's going to be 32. Now there's going to be a total mass, so we're just going to add it up. And my mass is going to be 44 unit grams per mole. And we're going to use that mole part a little bit later. It just means one quantity of CO2 has a mass of 44 grams per mole, or 44 grams for each one. Now, let's go ahead and do another one. That was a simple one. They sometimes get a little bit more difficult. I'm going to use one that's going to use a different number, and this is one where we're going to have to distribute to figure out our number of atoms. Now, if I'm taking a look at the numbers, I'm going to try to be a little specific instead of actually, trying to round it off. Copper, there's only one of these guys. I have distributing the 2, it's going to be 2 times 1, so I'm going to have 2 oxygens, and then I'm also going to have 2 hydrogens. That kind of shows the importance of actually writing correct formulas, because it could throw your calculation off. Now, if you take a look at the sheet, you're going to notice that the mass of copper is 63.55. We usually use 63.5, but if you notice, it's kind of right in the middle part. So if we have a little bit higher amounts, sometimes you have to go past the decimal point since it's in the middle. Oxygen still 15.999, which is 16, and hydrogen is 1.008, pretty close to 1. And then I just go 2 times 1 is 2, 2 times 16 is 32, and I got a 63.55 as far as my mass here. If we add it up, it's going to be 797.55 grams per mole. Again, that's kind of showing you how to do the mass. And then we kind of work off of this mass, or this lower concept, for all these higher concepts. That is the reason why we actually need to write out our work. Now let's do another mass calculation. Let's say I have Mn C2O4 with a 7. This one's going to actually have a higher mass. So if I have a higher mass, no, I'm doing a video. If I have a higher mass, like with this one, I still go through the same procedure. I got 2 of my manganeses. I've got 14 carbons because I distribute this and multiply. So 7 times 2 is 14. And then 7 times 4 is 28 for my oxygens. Now, it may be very useful in order to have a calculator because sometimes your numbers are going to be a little higher. So I'll have the calculator available. But I know that the mass off of here is, with manganese, is 64.94. I can go 55. That's fine. Now with my carbon, it's 12.011, which is 12. And oxygen's pretty close to 16, so we'll go 16. Now if I go ahead and do my numbers here, this is 110. Now this is the reason why we have to use a calculator sometimes, because sometimes we have a little bit of a problem working on those bigger numbers. And if you add them up, (726) grams per mole, which again just means if I have one of these guys, or one of these quantities of this, that would be my mass, which is in grams per mole. There's only one more that's going to be a little bit different. So let's go ahead and do, let's see, let's do K2SO4 Okay, so the name of this would actually be potassium sulfate pentahydrate. This guy here is not a multiplication sign. This means I'm adding 5 waters to it. The reason why they add water is because if this gets up in the air and you inhale it, it could cause cancer a little bit later on. So what I'm going to do is I'm going to work on the numbers again. I have 2 potassiums. I have 1 sulfur. And I have 4 oxygens. And I have 5 waters. And I'm just going to go ahead and just put it down here. That's kind of also a great reminder as far as I'm needing to add all these up, because it is a total mass. Again, this guy means with, not multiplied. It's an added mass. You'll notice that potassium, it's 39.098, I believe, which they sometimes go with 0.1. 39 should be okay with this. This is 32.066, 32, 15.999, which is 16. And with this guy here, that would normally be 18.015, but we'll go 18. Again, 78, 32, 64, and this one will be 90. And then again, I add up the whole thing. So this one, 110, 174, 264 grams per mole. So that would be how you do a mass calculation with a hydrate. Again, it pretty much is the same procedure. It's just instead of multiplying with that dot, I'm just going to add it because that dot means width.